Hi everyone, so now we're going to talk more about triangle congruent statements, and in this video we'll talk about how to determine if two triangles are congruent and then how we know that. So there's 4 different ways that we can decide if triangles are congruent, or prove congruence I should say, and those are SSS, SAS, ASA, and AAS, where the S's stand for side and A stands for angle. So we're going to kind of go through those first and then go through the examples. So for SSS, which stands for side, 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 what we need to do is prove that each side has a congruent side on the other triangle. So for example, if I know this side has the one line and this side has the one line, those two are considered congruent to each other. Then these, let's say we've got 2 green lines over here, those would be congruent to each other. And then let's say I've got 3 red lines, so those are congruent to each other. So when I see a triangle like this, then I know that it's congruent by SSS, or side, 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 because all 3 sides have congruent other sides on the other triangle. Now, the next way is SAS, which is side, angle, side. So we have the 2 sides, right? I'm going to start with that first. I know that I'm going to have one side equal to each other and then another side. And then you have one angle. So your angle, because it says SAS, the angle has to be in between the 2 sides. So my angle in this case has to be on the top, mostly because of the way that I wrote out the sides. Now, if I were to have used like the bottom side, then I could have used one of the other angles, but you want to make sure that you're using, like, when you have to put them in order, so it has to go side, then angle, then side. So for example, if I had used this angle, then it wouldn't have worked, because you would go from this side to this angle, but then you have this blank side right here, and that doesn't work. You need the other side right across from the angle, or right next to the angle, to be the congruent one. So it has to be set up this way. So there's side, angle, side. And then angle, side, angle, we have 2 angles. So I'm going to start with our 2 angles. Let's put one angle right here, and then let's put another angle up here, that we know that those 2 are congruent to each other, right? And this is the kind of the same thing as that side, angle, side. We want to make sure that it's in order. So the side that goes in between the 2 angles has to go in between the 2 angles. It has to be this one, because then if you start down here, you've got angle, then side, then angle. Okay, that's great. Let me show you on this one really fast. If I were to have made it this side, then it would have gone angle, then side, and that's a different one. So we can't use that one for this example. And we want this guy right here. So the side is in between the 2 angles. Then the last way that we can prove congruence is with angle, angle, side. So once again, we have 2 angles, and I'm going to start with those 2 angles. And then the side isn't in between them, right? The side is on the outside of them. So this one actually works out a little bit better, or is a little bit easier to see. You can do this side, because then it goes angle, angle, side, or potentially I could do the bottom, because that's the same, like, then it would go angle, angle, side. We would just kind of go around the other way. Excuse me. You don't have to go one around a specific way. It's just that you want to make sure that the side, for angle, angle, side, it has to go angle, then side. The side isn't in between the angles, or else it would have been the other one, the angle, side, angle. Okay, there are only a couple of other combinations you can make with these letters, S and A. One of them is angle, 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 and that does not prove congruence, because even if your angles are exactly the same, your sides could be different lengths, which, remember, congruence says that they need to be all of the same lengths for the sides, so that doesn't work. And then the other one is SSA, or ASS. That one also doesn't prove congruence, and the way that I remember is because it spells a naughty word, so we can't use it. Okay, so let's go through some examples that you have on your sheet. The first example looks like this. Let's see. obviously, I did not draw these correctly, but when you're looking at this, you're saying, okay, well, each of them have 3 sides that are congruent to 3 sides on the other thing. Because of that, we automatically know that it's side, side, side. So that's how we're going to prove congruence. Okay, then the next example looks like this. Once again, I know I'm not an artist, but we have this, 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 this. Now on here, we only have one angle and one side. So automatically we're kind of thinking, well, there's not enough information, right? But there's a couple of things on here that I wanted to show you. So when you have angles that are right across from each other, like these 2 blue angles, they are called vertical angles, and vertical angles are equal to each other. So you're gonna see some of these on your self-check. You just wanna, the way that I like to do it is if I see something with a vertical angle, I just automatically show that it's a vertical angle or that those 2 angles are equal to each other, so that way I can decide what congruent statement to use. So we know those 2 things are congruent. So now when I just look at one triangle, I have a side and an angle and an angle. And so my congruent statement, automatically, I know it's going to be angle, angle, side. All right, let's go to the next question, which looks like this. Let's see. 1, 2, 3. So on here, we've got 3 angles, right? So if there was such a thing as angle, 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 yeah, that would totally be our answer. But because there is no such thing as angle, 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 because we can't prove congruence from that, we're just going to say not congruent. And that would be our final answer. Like there's no way to prove congruence in this situation, so we're going to say that it's not congruent. Okay. And then the last example looks kind of like this. Okay, so we've kind of talked about this in one of the other videos too, but if you notice, these 2 triangles share a side. So I'm going to draw this line right here that shows that that side is equal to each other. When a triangle shares a side, then automatically we know that they're equal to each other. So now we're going to look and we're going to say, well, if I'm just looking at, let's say, the top triangle or the triangle on the right, we know this angle is congruent. We know this side is congruent because it shares a side. And then we know this angle is also congruent. And so if I put them in order, that would be angle, side, angle. And there is my congruent statement. So those are your 4, let me scroll up so you can see again, but these are your 4 congruent statements. And that is how you prove congruence.